So for this example, we need to find the derivative of f of x equals 3x to the power of -7 plus 9x squared. And remember, our formula for the power rule is d dx, x to the nth power equals nx nth power minus 1. So the best way to approach this is to separate it by terms. So first we'll work on this one, 3x to the power of -7, and then we'll move on to working on the 9x squared. So our n value is our exponent, which in this first term is -7. So let's just write that out. So we have d dx, 3x to the power of -7, and that will equal -7 times 3 x -7 minus 1. And that's going to simplify if we times the -7 by 3, -21 x, and then -7 minus 1 would give us -8. So the derivative of 3x to the power of -7 is -21x to the -8th power. So now for term 2, we have d dx, 9x squared. And remember, our n is our exponent, which in this term is 2. So we'll have 2 times 9x, 2 minus 1 in the exponent. And if we simplify, 9 times 2 is 18. X, 2 minus 1 would just equal 1, which would just leave x. So the derivative of 9x squared is 18x. So our final answer, the derivative of f of x, or f prime of x, equals -21x to the power of -8 plus 18x. This right here would be our final answer. Okay, for our next example, we're going to try to find the derivative of f of x equals 2x to the power of 1/2 plus 3 times the square root of x. So remember that we're working with the power rule, so we want to see exponents, not square roots. So for this first step, let's go ahead and change this square root into the notation of a power. So that would look like this. We have 3 times the square root of x, which is equivalent to 3x to the power of 1/2. We just changed it to have an exponent, so that would change the original function. F of x equals 2x to the power of 1/2, that stayed the same, plus 3x to the power of 1/2. That's it. And now we can go ahead and use the power rule to take the derivative. Remember, this is our original formula. So let's start with the first term, which is 2x to the power of 1/2. So we have d dx, 2x to the power of 1/2. And our n here is our power, which is 1/2. So we bring down the 1/2 times 2x, 1/2 minus 1, which would simplify. If you times 1/2 times 2, that would just leave us with x. And then we would 1/2 minus 1 would just be -1/2. So the derivative of 2x to the power of 1/2 is just x to the power of -1/2. This is for our first term. And then for our second term, we have d dx. And remember, we changed the notation, so it would be 3x to the power of 1/2. And this would equal 1/2 times 3x to the power of 1/2 minus 1, which would simplify to 3/2 x to the power of 1/2, -1/2. Right? So the derivative of 3x to the power of 1/2 is 3 over 2x to the power of -1/2. So then our final answer would be f prime of x equals x to the power of negative 1/2 plus 3/2 x to the power of negative 1/2. This would be our final answer. Well, I didn't mention this earlier because truthfully I didn't even notice it, but these two are right up here. They're like terms, so you could have added them together in the beginning to get 5x to the power of 1/2, but even now at the end, they remain like terms, so you can still simplify further. So you could simplify this to f prime of x equals 5/2 x to the power of negative 1/2. And if you want to simplify further and put it into a notation of a fraction, you would get f prime of x equals 5/2 times the square root of x. So this answer, this first one right here, it's equivalent to this one right here and equivalent to this one right here, but you also could have added the terms together at the very beginning, but they're all still the exact same answer, just written in a different notation or simplified a bit further. But I just wanted to point that out. Okay, so here we need to find the derivative of f of x equals 4/3x squared. And just like in our earlier example, square roots aren't easy to work with, and neither are fractions. So if we rewrite this as 4/3 times x to the power of negative 2, it'll be a bit easier to work with. All I'm doing is pulling the x squared out of the fraction. So this right here is equivalent to this right here. I'm just rewriting it differently, so it makes it easier to work with. So now we can apply our power rule, which would look like this. We bring the negative 2 down, times by 4/3, and then we have x, the power of negative 2, minus 1, which is simplify. If we do negative 2 times 4/3, we would get negative 8/3. And then we have x, negative 2 minus 1 gives us negative 3. And then if we rewrite it again as our original fraction, we would get negative 8 3x cubed. So the derivative of 4/3x squared is negative 8/3x cubed. Okay, let's find the derivative of f of x equals x cubed minus 4/x squared. So remember, fractions are not easy to work with, so let's rewrite the notation. So we have f of x equals x cubed, that can stay the same, minus 4x to the power of negative 2. This is equivalent to this. It's just written in a different notation, so it makes it easier to apply the power rule. So now let's apply the power rule to our first term, which would be 3x, 3 minus 1. And then for our second term, we would be minus, and then we have negative 2 times 4x, negative 2 minus 1. So if we simplify that a bit more, we will have 3x squared plus, because this negative and this negative would give us a plus, and then negative 2 times 4 would give us 8. X, and then negative 2 minus 1 gives us a negative 3. So the derivative of f of x equals x cubed minus 4/x squared is 3x squared plus 8x to the power of negative 3. Okay, so for this example, let's find the derivative of f of x equals 3x cubed plus 4x squared over x. Again, remember, fractions aren't easy to work with, so let's rewrite the notation. So we'll have f of x equals 3x cubed plus 4x squared times x to the power of negative 1. And we're just going to go ahead and distribute the x to the power of negative 1. And that would give us f of x, so 3x cubed times x to the power of negative 1 would be 3x squared. And then 4x squared times x to the power of negative 1 would just give us 4x. So now we've distributed that. Now we can go ahead and apply our power rule. So if we apply our power rule to our first term, which is 3x squared, we would get 2 times 3x 2 minus 1 plus, and then our second term 4x, we would have, it would just be 4. So then we have, this would simplify to 6x plus 4. So the derivative of 3x cubed plus 4x squared over x is 6x plus 4. We just rewrote the notation, and then we distributed this x to the power of negative 1, which gave us these numbers. Then we applied the power rule to each of these, and that gave us 6x plus 4. Next, let's solve for the derivative of f of x equals 4x to the 4th power minus x over x cubed. I've said this many times already, but fractions are not easy to work with, so let's rewrite the notation. That's going to be our first step. So this would look like f of x equals 4x to the 4th power minus x times x to the power of negative 3. So remember, this right here is equivalent to our original function. I just rewrote it so that we don't have to deal with fractions. So then our next step is to distribute the x to the power of negative 3. So if we distribute it, it would look like this. So 4x to the 4th power times x to the power of negative 3 would just give us 4x minus, again, x times x to the power of 3 would give us x to the power of 2. So now we've just simplified our function a bit more, and now we can go ahead and take the derivative using our power rule. So f of x for our first term would just be 4. And then we have minus, for our second term, negative 2 times x to the power of negative 3. And then if we simplify that a bit more, we have f of x, f prime of x, equals 4 plus 2x to the power of negative 3. And if we want to rewrite it again, so this right here would be our answer, but if you want to rewrite it again in a fraction, it would be like this. F prime of x is 4 plus 2 over x cubed, if you just want to get rid of the negatives. So this right here would be our final answer, which is also equivalent to this answer. This answer is just written without a fraction. This answer has a fraction. So whichever way you like to answer, you can use either one. They're both correct, just different notation. Here we need to find the derivative of f of x, x squared times 6x squared minus 2x. So if you haven't already noticed it in this video, one of the most important skills you can have in calculus is to A, know how to distribute, B, know how to change between notation, whether you use exponents or fractions, and be able to go back and forth. So if you've already mastered that, you probably already guessed that we have to distribute this x squared to both of these terms. That's going to be our first step in this function. So that will leave us with f of x equals x squared times 6x squared, which would give us 6x to the 4th power. All I did was times x squared times 6x squared. And then we have to distribute it to the second term, so x squared times 2x would give us 2x cubed, right? So now we can go ahead and take the derivative using our power rule, which will look like this. So we have f prime of x would equal 4. Remember, we bring our exponent down, times the coefficient 6, our variable x, 4 minus 1. And then for our second term, we have 3 times our coefficient 2, x, 3 minus 1. So this is going to simplify to 6 times 4 is 24. 24x, 4 minus 1 would just give us 3. And then for our second term, negative 3 times 2 gives us 6x. And then our exponent 3 minus 1 equals 2. So the derivative of x squared times 6x squared minus 2x would be 24x cubed minus 6x squared. For this final example, we need to find the derivative of f of x equals the square root of x minus 7 times the cube root of x plus the cube root of x. So remember, we don't want to work with square roots. We want to work with exponents because we're using the power rule. And to use the power rule, we need to have exponents. So the first step is going to be to change every single root into exponents. That's always going to be our first step if we don't have any roots. So that would look like this. F of x, for our first term, it would just be x to the power of 1/2 minus this 7 would stay the same, but the cube root of x would turn into x to the power of 1/3 plus x to the power of 1/3. Remember, this 3 times the square root of x is completely different from the cube root of x. These two are not the same thing. So be careful when you look at that. Make sure you're rewriting it in the correct way. Okay, so for the next step, so we've turned all of our roots into exponents, and now that we have roots, we can go ahead and take the derivative using our original formula for the power rule, which is d dx, x to the nth power equals n, x to the nth power minus 1. So if we apply that to the first term, we're going to get f prime of x equals 1/2 x, and then 1/2 minus 1 would give us negative 1/2. And then for the second term, we have the 1/3 times the 7x, and then 1/3 minus 1 would give us negative 2/3, plus 1/3 x, and then 1/3 x minus 1 would give us negative 2/3. So if we simplify this term right here a bit more, our final answer would be f prime of x equals 1/2 x to the power of negative 1/2 minus 7/3 x to the power of negative 2/3 plus 1/3 x to the power of negative 2/3. So the derivative of f of x equals the square root of x minus 7 times the cube root of x plus the cube root of x would be f prime of x equals 1/2 x to the power of 1/2 minus 7/3 times x to the power of negative 2/3 plus 1/3 x to the power of negative 2/3. That would be our final answer for this one. Okay, I lied. I have one more thing to say about this one. So if you wanted to simplify further, you could, because we have like terms right here with this one and this one. So if we combined those two, we would actually get negative 6/3 x to negative 2/3 if we combine those two. And this would simplify further to negative 2x to negative 2/3. So simplified, our final answer would be f prime of x 1/2 x to the negative 1/2 power minus 2x to the negative 2/3 power. If you wanted to simplify further, you could have also simplified up here because these two are like terms. But either way, it's essentially the same answer. This one is just a lot more simplified and maybe easier to read, but that's only if you want to simplify more. Just wanted to make a note of that.